What if the biggest computing revolution since the internet does not arrive slowly? What if it arrives as a deadline? IonQ has published a roadmap that points to 20,000 physical qubits in 2028 and up to 80,000 logical qubits by 2030. If that sounds abstract, here is the real question. What happens when computers stop being just faster calculators and start becoming machines that can simulate nature itself? Right now, quantum computers are still young. They are fragile, they are noisy, and most of them are not ready to change your daily life. But the curve is starting to bend. In 2026, IonQ is targeting systems in the hundreds of physical qubits. In 2027, the target jumps to 10,000 physical qubits, roughly 800 logical qubits. Then comes the number that makes people in security, chemistry, and computing pay attention: 2028. 20,000 physical qubits, around 1,600 logical qubits. That is not just a bigger machine, it is the doorstep of fault-tolerant quantum computing. In normal language, it means a quantum computer that can keep correcting its own mistakes long enough to do useful work. And the roadmap does not stop there. For 2029, IonQ lists 200,000 physical qubits and around 8,000 logical qubits. For 2030, 2 million physical qubits, with up to 80,000 logical qubits. This is why the timeline matters. For years, quantum computing sounded like a technology that was always 10 years away. Now companies are putting actual dates and actual engineering targets on the table. IonQ also announced a 99.99% 2-qubit gate fidelity result. That number matters because fidelity is basically how often the quantum operation behaves the way it should. The higher it gets, the closer you move from impressive laboratory demos to reliable computation. So what could this unlock? First, chemistry. Nature is quantum. Molecules, proteins, catalysts, batteries, superconductors, all of them depend on quantum behavior. Classical computers can approximate this, but the complexity explodes fast. A fault-tolerant quantum computer could simulate molecules with a level of detail that today is brutally expensive or impossible. That is why drug discovery is one of the most serious applications. Instead of testing endless guesses in the lab, researchers could screen molecular behavior far more directly. Not magic, not instant cures, but a massive acceleration in how we search. Second, materials. Better batteries, more efficient solar cells, new catalysts for clean industry, maybe even materials that look impossible with today's methods. The point is not that quantum computers will invent everything overnight. The point is that they may reveal options we cannot currently calculate. Third, encryption. This is the part everyone clicks on because it sounds terrifying. And yes, there is a real reason to worry. Much of today's public key encryption, including RSA and elliptic curve systems, is vulnerable in principle to sufficiently powerful fault-tolerant quantum computers. That does not mean your bank account gets broken tomorrow. It means the migration clock is already ticking. The scary strategy is called harvest now, decrypt later. Attackers can steal encrypted data today and store it. They do not need to read it now. They just need to wait until future machines can break the protection. That matters for anything that must stay private for years: medical records, government files, legal documents, financial data, private messages, and corporate secrets. The good news is that post-quantum cryptography already exists. NIST has standardized algorithms designed to resist attacks from both classical and quantum computers. The bad news is that changing the world's cryptography is not like updating one app. It means banks, governments, cloud providers, hospitals, software vendors, and old embedded systems all have to move. That is why 2028 is such a powerful date. It is not a prophecy that the internet ends. It is an engineering alarm bell. If IonQ hits its roadmap, the conversation changes from "Will quantum computing ever matter?" to "Who is ready first?" Because the winners will not be the people who panic in 2030. The winners will be the people who prepare before the machines arrive. The quantum era is not just about speed. It is about control over chemistry, materials, security, and computation itself. And if this roadmap holds, The leap begins in 2028. Subscribe to Science in 5 Minutes if you want to stay ahead of the technologies that will define the next decade.